9702 February March 2023, right? And variant is 2. Paper is paper 5, planning analysis and evaluation. Right? Let's start. Question number 1. An electric pump is placed in a container of a liquid. A model wind turbine is connected to the pump by a cable and so, right? The turbine is placed in moving air. As the turbine blades turn, electricity is generated and the pump pushes the liquid through a vertical pipe. The frequency of the rotation of the turbine blade is F. Is the height of the liquid moved is H. The mass per unit time of the liquid leaving to the top of the pipe is Q. It is suggested that the Q is related to F, right, by the relationship this. So if I say from the equation is both are in the numerator, so it has somehow a direct relationship. More frequency and more pumping to the pump mass per unit time will be high. Where G is acceleration of free fall, C and D are constant. Plan a laboratory experiment to test the relationship between Q and F. Draw a diagram showing the arrangement of your equipment. Explain how the result could be used to determine the value of C and D. And your plan should include the procedure to be followed, the measurement to be taken, the control of variables, the analysis of the data, and the safety precautions to be taken. Right. So here is my uh, diagram. A little bit difficult to observe, but let me elaborate. This is the iron stand, and I fit in a dynamo. A dynamo produces electricity when it starts rotating, right? And and in front we have a blade, right? And with the another iron stand, I put a hair dryer so that allow the blade. So when the air blows, it will turn the blade, and the dynamo start producing electricity from the wire. This wire, right? So we have an electric pump, right? And the pump we have with the help of a pipe store the water with a a beaker in a height placed with the tank with an iron stand again, and beneath it we have a digital meter to measure the mass of the water collected in the meter. And for somehow we are recording with the video camera of or the mobile camera every steps, right, to measure the record the time, right, because we need to know the time because of after we do that we will able to find the frequency, right, of the blade to move and the time to which it store the water over here, right. So this is the setup. So independent variable is the rotation of the blade, which is frequency, right, measured from the and we could measure from the period t, because we know the frequency and period are t are reciprocal to each other, and t is recorded from with the help of a slow motion moving camera. Dependent variables are the mass of the water, right, collected by the empty beaker with the time recorded with the help of digital meter, right, and the time means the mass is recorded with the help of the digital meter, and the video time q equals m over t, right, which is actually a, and the control of the variable is height with the ruler, right. So we have the height over here, right, and the method with the help of hair dryer, dynamo start generating electricity, right, as blade moves, and then dynamo gives constant current to the dynamo gives current to the pump. that pull water to a height and collect to an empty beaker. This all activity is recorded in the video and the related data like mass and time will be collected, right? Repeat the experiment and collect the data with different set of time and mass. Frequency of the blade is calculated by F equals 1 over T. Precautions. Placement of the video recording recorder or the mobile should be in the correct position. Placement of the dryer to give a full air blow to the blade, right? And we need to uh, use gloves. Gloves should be used. Gloves should be used to to handle the blade, right? So the analysis should be like QGH equals C plus DF3. So if we take the Q as a subject, right? Because it is a mass over time, which is depending on the frequency. So it should be like C over GH and GH is FQ. So if we compare with that Y equals MX plus C, so Y will be the Q, X will be the FQ, and the Y intercept is G, C, G and H, and the gradient is D over GH. So by if we after having several data collection, after we plot the graph, right, we will get the C, the gradient, and the y-intercept G is G over H. So we will get the gradient, equated. We will get D like C, which is a gradient, M equals D over GH. So D will be equal to MGH, right? And the C means the y-intercept. Y-intercept is y-intercept we will get from this, right? Or you can say del y equals C over GH. So it will be C equals del y G and H. So we will get this from the graph plotting. So this will be finished our question number 1.